Today we are studying Equilibria in aqueous solutions. What are first of all we will see some salts, sparingly soluble salts. Like we study solubility constant first. Okay, equilibrium concentration of slightly soluble salts can be obtained using principle of chemical equilibrium. Here you can see an example of silver chloride. It dissociates when it dissolves in water. It dissociates into silver ions and chloride ions. Okay, it has value of this, like you can say solubility value of this at 25 degrees Celsius. Okay, here you can see equation, solubility equation for silver chloride in water. Okay, uh, we use, like, first of all we will write the equilibrium constant equation, then we will get solubility constant equation. Okay, KSP is solubility constant, and these are the ions which are which forms when silver chloride dissolves in water. Okay, KSP is also known as ionic product constant or solubility constant. It is an equilibrium constant for sparingly soluble salts where products of concentration of respective ions produced due to ionization. Okay, here we have given KSP of the AgCl salt. Okay, there we have asked to find out the, so like you can say, solubility of each ion. Okay, we have this, we will use this equation here and write value of KSP, and we can say that there are two ions. We can write each ion as x. Okay, each ion as x, so this will be x square will be equal to 2.8 is equal to this value. Okay, when we take square root on both sides, after taking square root we will get this answer, 1.7 multiply 10 raised to power minus 5 molar. Okay, and same we will get same value for chloride ion as well, as both are in equal ion, have equal ions, one ion for silver and one ion for chloride. Example of CF2 here, you can see here it forms one ion of calcium and two ions of fluoride, and it will be written like this way, chloride ions like this way, F minus, okay, 2 in bracket here and 2 as power of, okay, this will be written as this, and for calcium we will write like this, C plus 2. Okay, so we will write this value as of fluoride, you can say 2x into square. Okay, and for calcium x, then we will get 2x, 4x. When we solve like 2x square and x, we will get 4x cube. We have to find the S. Okay, solubility of the ion. Okay, then we will solve this. Okay, we will get 3.5 raised to power 10 raised to power 4 molar for calcium. Okay, this was the solubility product. Okay, these questions came, like you can solve in this way to get the answer. Okay, now we have common ion effect. What is common ion effect? The suppression of the association of the weak electrolyte on its addition of its own ion is called common ion effect. We can see that to understand the solubility of a solid, let us calculate solubility of HgCl. We have find 0.1 molar AgNO3 solution. Add AgNO3 in a saturated solution of HgCl to reach the concentration of 0.1 molar. The addition of AgNO3 will disturb the equilibrium. Now, according to Le-Chatelier principle, when a stress is applied on a system in equilibrium, the system tends to adjust itself so as to reduce the stress. That means the position of the equilibrium will be shifted. As we, for example, our reaction is moving in the forward direction. If we add some products, the reaction will move in the backward direction according to Le-Chatelier's principle. Okay. Thus, we add AgNO in saturated solution of HgCl. HgCl must tend to precipitate. Thus, we can say that solubility of HgCl in a solution of 1 molar solution, 0.1 molar Ag positive ions is less than the solubility of HgCl in pure water. Okay, you can write these equations. Okay, examples. Okay, you can solve this. Selective precipitations In both qualitative and quantitative analysis, we can take the advantage of the difference in solubility of salt to remove only one salt from the several salts in solution. Calculation using probability can tell us when separation of this type is possible. Okay, so you have to practice these types of questions to get better understanding. Okay, another question here. Okay. Okay, these are the questions. Acid and bases. Okay, this is the important topic. Like you can say, this is the like you can start this one and have to get better understanding about this. Okay, acid-base reaction includes number of chemical changes. Okay, first of all, first concept is Arrhenius theory of acid and bases. According to this theory, when acid dissociates in water, it gives H positive ion. Okay, and when base dissociates in water, it gives OH negative ions, means hydroxyl ions. Okay. Here you can see an example, HCl. HCl gives H positive ion, so HCl is an acid according to Arrhenius theory. Okay, and this is carboxylic acid. Okay, this gives H positive ion, so this is also an acid. This is acetic acid. Degree of dissociation of different acids is different, so different acids have different strengths. Okay, similar scheme can be applied on NaOH. NaOH gives Na positive and OH negative ions. OH negative ions, so NaOH is a base. MgOH2 gives OH negative ions. MgOH twice is a base. Okay. Thus, proton is responsible for acidic properties and hydroxyl ion is responsible for basic properties. This theory has certain limitations. First is concerned with the nature of proton in aqueous solution, and second is the substance which do not contain OH also act bases. Okay. Water is an excellent solvent for ionic compounds. In aqueous solution are stabilized by the strong attraction of the molecules. Proton is a unique radius of H positive is just the nucleus. This is like some information like radius of ions and radius of nucleus. Okay. When HCl reacts with H2O in aqueous solution, it gives Cl negative ions. Okay, and H positive is taken up by H2O. Okay, an acid is a molecule capable of transferring or donating a proton to another molecule. This is the limitation of Arrhenius, first limitation. And the limitation is that it says that all the basic properties are the hydroxide ion, but this is not true. There are some substances which do not have hydroxide ion can act as bases. You can see here NH3. NH3 is a base. It doesn't have an OH negative ion. So according to Arrhenius, bases are those substances which give OH negative ion in water. But you can see here NH3 doesn't contain any OH negative ions. So how it can be a base? So this is the limitation. Arrhenius was unable to explain this. Okay, so this was the limitation of Arrhenius. Bronsted-Lowry concept. According to this concept, acid is a species which have tendency to lose or donate a proton, and a base species has a tendency to accept a proton. Okay, acid HCl base. Yeah, H2O is base as well as acid. It is empty nature, like empty, you can say two natures. Okay, like it can act as a base as well as an acid. Okay, here it is acting as a base. HCl gives H positive ion to water. It gains an electron and it becomes a base, and acid HCl becomes a acid because it donates a proton. This reaction is reversible. Cl may accept a proton from H3 positive and become HCl. Thus, fluoride ion is a base. This is the conjugate base. This is the conjugate base of acid HCl, and H3O positive is a conjugate acid of base H2O. Okay. Since HCl and Cl negative and differ only by protons, so they are known as conjugate acid-base pairs. Okay. You can see here. Okay. And the behavior of carbonate ions can also be represented. You can see here acid here is water. Water is acting as an acid here, but here it was acting as a base. Okay, so it has two natures. It can act as a base and it can act as a acid because it can donate proton and it can gain proton. Okay, the Lowry-Bronsted concept doesn't contain OH negative as a base. Okay, so but according to Arrhenius, or that base is a that species that contains OH negative ion, but according to Bronsted, that is not the case. Okay, strength of the Bronsted-Lowry definition suggests that a strong acid has tendency to transfer a proton to another molecule, and a strong base has a larger tendency to accept a proton. Thus, acid strength can be measured by quantitatively by the extent to which reactants are converted into products. Okay, another example here you can see SO4 negative and H2O. Lewis concept. According to Lewis, an acid is a substance that can accept pair of electrons. Okay, that can accept a pair of electrons, and a base is a substance that can donate a pair of electrons. Okay, you can see here BF3 and fluoride ions, this react and form BF4 negative, Ag2Cn negative, and forms this compound. Okay, this concept is also used for reaction in which protons are not involved. Okay, so if you are given a question of any type, like you first have to see Arrhenius, then Bronsted-Lowry, and then Lewis concept, so you can get better understanding what concept this question belongs to. Okay, so you can mark the correct answer. Okay, the pH scale. pH scale is a concentration in moles per liter expressed as negative of powers. Okay, pH is this formula. You can use this formula for calculations. Okay, water is self-ionization, gives positive and OH negative ions when dissociate. pOH is like negative of the logarithm of the hydroxide ion concentration, but pH is the negative or logarithm of positive H positive ion concentration. Okay, this is all you can say constant for water. Okay, like you just need to remember these formulas for finding pH. Okay, and pH scales from 1 to 14 as well, and pOH scales also from 1 to 14. Okay, there is a common formula for pH and pOH, that is pH plus pOH is equal to 14. That the sum of pH and pOH must be equal to 14. Hydrolysis. A weak acid and its anion are conjugate acid-base pairs. If an acid is weak, its conjugate base is a strong. This is a weak acid. You can see here, acetic acid is a weak acid. Its conjugate base is strong. This is conjugate base. Okay. This reaction is a hydrolysis of the acetate ion. KH is known as hydrolysis constant, KH. Okay. You can see here KH is equal to water constant. Okay, that's Kw and Ka for acid. Okay, it is clear that the weaker acid, smaller the Ka value, and the corresponding anion will be hydrolyzed strongly. In other words, it is a quantitative demonstration that weaker the acid, stronger is its conjugate base, and vice versa. Then if we have a stronger acid, then its conjugate base will be weaker. Okay, here you can see acetate ion is a weak base. So the most of acetate ion remains as in the solution. This is our second assumption. First assumption was self-ionization of water to OH concentration can be neglected. We find the OH concentration. Okay. Kb is for the base. This is constant. Okay, for base. Okay, solid of base. KH, I told you earlier as well what is KH, hydrolysis constant. Okay, yeah, see this reaction, ammonium ion and water. Okay, it reacts with water and give NH3 and H3O positive. NH4 is a weak acid, so its base will be a strong conjugate base. Okay, strong conjugate base. Okay, a solution that contains appreciable amounts of both acid and its salt is called buffer solution. Buffer solution has remarkable and useful properties. Buffer solution can be diluted without changing an H3O positive concentration. These are some cases here. You can see this. Okay. indicators I think not involved, but just find out, you can say, there how indicators behave, what colors they give, going from acid, weak acid towards the strong base, okay. Remember, you can just what happens when we add base, acid, what effect indicators show, okay. These are some examples of related to solubility. So scroll down. Okay, you can like skip these seconds, okay, or pause the video, okay. Here are some multiple choice questions here. I was just like here. Scroll throughout. You just close the video and see these questions. Okay. Answers are marked. Okay. Okay. I hope you like the lecture. That is for the topic. Good luck.